Hello everyone. Today we are going to learn about distributed consensus mechanism, that is proof of work. Learning outcome of this session are: at the end of this session, student will be able to understand the concept of proof of work and how it's being used to secure the blockchain network. Student will be able to become acquainted with who's involved in the mining process. Recall, what is consensus? Consensus is a process of agreement between distrusting nodes on the final state of data. Proof of work is the original consensus algorithm in a blockchain network. It is used to confirm the transaction and creates a new block to the chain. In this algorithm, miners compete with each other to complete the transaction on the network. The process of competing against each other is called mining. Let us consider that transaction is initiated from A to B. This transaction is then broadcasted on the network where multiple peers are in existence. Then all the peers present in the network validates that transaction. Peer are nothing but different node, or we can say participant, which are involved in this transaction. So all of them validate that transaction. Then the block is created and that block contains the information about the transaction, and that block is added into the network. That new block is created and then block is added into the network. And finally the transaction is completed. And the transaction is completed by receiving money to the recipient. So this is what happens in the proof of work. Now how it works? Now miner gets rewarded who create valid block successfully. As we have multiple nodes involved in the network, there is one node who creates a valid block, and that node is rewarded for creation of the valid block. Proof of work is a technique used by cryptocurrency to verify the accuracy of new transactions that are added to a blockchain. The decentralized network used by cryptocurrencies and other DeFi applications don't have any central government authority, so they use proof of work to ensure the integrity of new data. So there is no central governing authority. Cryptocurrencies do not have centralized gatekeeper to verify the accuracy of new transactions and data that are added to the blockchain. Instead, they depend on a distributed network of participants to validate incoming transactions and add them as a new block on the chain. Proof of work prevents 51% attack or double spend problem. What is this? A miner or a group of miners on a blockchain trying to spend their cryptos on the blockchain twice, means spending the same unit in different places before the system can record the transaction. So this problem can be prevented by incentivizing the miners to verify the integrity of new crypto transactions before adding them to the distributed ledger, that is a blockchain. So double spend problem means same unit may spend twice. Okay, so this should not happen. So this proof of work minimize the double spend problem, or it resolves this double spend problem. Mathematical problems involved in proof of work. To solve mathematical problem, node requires plenty of computational power. So the first, it contains hash function. Hash function involves a process to generate a fixed length output with a given input, while a hash is a numerical value that decides who mined the block accurately. Then integer factorization. Solving integer factorization consists of composite numbers decomposition into small integers in conjunction with the prime number restriction and multiplication. Contingency puzzle protocol It is used to secure the network in a denial of service attack that requires a defined order. Now let us consider example of Bitcoin. Application of proof of work is Bitcoin. Bitcoin is a decentralized digital currency that can be transferred on the peer-to-peer Bitcoin network. Bitcoin transactions are verified by network nodes through cryptography and recorded in a public distributed ledger called a blockchain. Proof of work achieves the Byzantine fault tolerance objective. Now, what is Byzantine fault tolerance? Byzantine fault tolerance is a system capable of surviving failure associated with Byzantine general problem. That means a network can avoid situations where some node or miner attempt to act against the consensus. Means some node may attempt to act as a malicious. Okay. With the help of the BFT characteristics, the proof of work algorithm works in such a way so that the nodes can validate a block within a network by solving a complex mathematical problem, and though the node attempt malicious, still it will not affect the network. So the first node who get the solution to the mathematical problem receive the consensus permission to choose a block to add to the blockchain. As an exchange, the successful node gets the token as a reward. For example, in Bitcoin network, the reward is in BTC. So this proof of work consensus creates relatively healthy and transparent closed economy, mainly to encourage users to continue to sustain the ecosystem. Proof of work serves a model where node solves a mathematical puzzle to produce the next block added to the network. Block leaders which produce the next block are selected in a lottery-like format that corresponds directly to their contributed computing, that is hash power, to the process. There are two primary participants in the proof of work consensus model: miners and full node operators. Miners. The node that participate in the computation are called miner, and the process of solving the problem is called mining. The community of miner is required to perform significant work to solve each successive platform. Then nodes. Nodes needed to spend time in maximum computation. As such, the process consumes a huge amount of electrical power, which is harmful to the environment. The decentralized node in the network must verify the blockchain's cryptocurrency that is mined for a reward using individual miners' proof of work mechanism. Next, we have validators. Based on cryptographic proofs and Bitcoin's consensus rules, full node operators act as an ultimate validator of the network state. Full node client can also be miners and reject invalid block and transactions on the network. It takes an average of 40 and 60 minutes for validators to approve transaction in a blockchain network under the proof of work consensus mechanism. Pros and cons of proof of work. Advantages: it prevents denial of service attack, it is fair and transparent, it encourages the public's interest in maintaining a healthy network. Disadvantages of proof of work: it has high cost, it has highly complex puzzles, and it makes the problem more centralized as opposed to decentralized. Mining will fade off as the reward are no longer attractive. Now, coins using proof of work. Litecoin. Similarly to Bitcoin, Litecoin also features SegWit, in which the block size limit increases by removing the data from the network. What sets Litecoin apart from Bitcoin is its lightning fast transaction times at much lower cost. Then Dash. It boasts of faster and more private transactions in crypto space. Then Monero. This is another popular altcoin that uses proof of work consensus. As an open source cryptocurrency, Monero focuses on privacy, transparency, and decentralization through a public ledger. Then Bitcoin Cash. It is a spin-off altcoin from the Bitcoin network's hard fork. Though it uses proof of work, which may seem to be secure consensus, Bitcoin Cash is one of the severely damaged victims of 51% attack. Then Zcash. It aims to provide privacy through anonymity. Unlike any cryptocurrencies, the Zcash network uses same proof of work SHA-256 hash function as a Bitcoin. Then Ethereum. Then we have Ethereum Classic. So despite Ethereum 2.0 moving away to proof of stake, Ethereum Classic is still using the proof of work consensus to secure the network. So these are nothing but the coin using proof of work. These are the references. Thank you.